Hello friends, welcome in my video classroom. Friends, today I teach example number 3.17, 18 and 20. So first of all, our first example is look at the graph A to D carefully and state with reason which of these cannot possible represent one dimension motion of a particle. Friends, here one dimension motion means object is moved in any one direction. Okay, so in our first figure, look here, x versus t graph are available. Look here, for any time, look here now we have value of t is a 1 second. So 1 second have two different position at a same time, but it is not possible for one time particle have not two position. Okay, so in figure A, it is not for motion in one dimension. For figure B, here graph is velocity versus time. In this case also, for time 1 we get two different value of velocity, positive and negative. So it is not possible for motion in one dimension. In figure C, here graph speed versus time. Friends, we learn speed is always positive. But here, look here value of speed is negative. So negative value of speed is not possible. Hence, it is not for motion in one dimension. And figure D. Here, graph is available, path length versus time. Friends, we learn path length is always increase. But in this graph, path length is initially increase, after it is decrease. But it is not possible. So, we can say that for motion in one dimension is not possible. Friends, our next example is question. Our question is, figure show the x versus t plot of one dimension motion of a particle. Is it correct to say from the graph that the particle move in straight line for t less than 0 and on a parabolic path for t greater than 0? If not, suggest a suitable physical context for this graph. Friends, here graph is available. Here x versus t graph. In this graph, when time is increased, position is suddenly increased. But here we can say that particle move on straight line for t less than 0 is not possible. And move on parabolic path for t greater than 0. Because graph x versus t does not show the path of motion. From graph, if t is equal to 0 initially, look here, at that time x is equal to 0. Suppose we give example. Suppose for the tower, top of the tower, we falling one object and its initial time t is equal to 0. At that time its position x is equal to 0. And our last example is figure gives the x versus t plot of a particle executing one dimension simple harmonic motion. Friends, you will learn about this motion in more detail in chapter 114. Give the sign of the position, velocity and acceleration variable of the particles at t is equal to 0.3 second, 1.2 second and minus 1.2 second. Friends, in chapter 14, I teach formula for simple harmonic motion for acceleration is a is equal to minus omega square x. Here omega is a angular frequency and x is a position. And we know that velocity is equal to dx upon dt, means distance upon time. Now we have different three value for time. T is equal to 0.3, 1.2 second and minus 1.2 second. So first now we take t is equal to 0.3 second. Look here. Here time is 0. Suppose here 0.5. So here exact value is 0.3 second. Okay. So here x is negative and slope is also negative. So value of slope is equal to value of velocity. So velocity is also negative. But here now we put value of x is negative. So negative negative plus. So for time t is equal to 0.3, we get value of acceleration is positive. Okay. For second, t is equal to 1.2 second. Look here, this is a 1 second. So exact here, time t is a 1.2 second. Here x is positive. So slope of the graph is also positive, means velocity is positive. But here value of x is positive, but now we have already negative sign. So we get value of acceleration is negative according to this formula. And last, time t is equal to minus 1.2 second. Look here time is equal to minus 1 and look here exact here. Time is a minus 1.2 second. So here value of x is negative. And here time is also negative. So velocity of the particle is positive. Here slope is negative, but velocity is positive. And value of x here we substitute minus. So minus minus positive means we get here acceleration is positive. So friends, today our chapter is finished. you prepare all this sum. It is very useful for our exam. Thank you.